channel Learning with Khatak. This is the fourth one lectures of the neural network series. In the first lectures, we just cover the neural networks and then how neural networks is called artificial neural networks and the basic structure of neural networks. This is based on the biological neurons structure of the brains. In the second lectures, we have delivered a lecture about the activation functions, how different activation functions are used in neural networks, what are the role of activation functions, how the inputs and weights are combined in the activation functions, and then how the activation function is fired. Basically, we have defined some criteria for the activation functions that how activation function will forward the input to the next layer. And in the third lectures, we have shown the implementations of different activation functions using inside the neurons, inside the artificial neural networks. There we use a data sets, ManSet data sets for classifications where we have implemented different activation functions. Now in this video lectures we will show that how do neural network works. Basically, neural networks is a classification algorithm used for binary classification and for multi-class classification problem. If you want to classify binary classification problem, you can also use the neural networks by using binary activation functions. And if you want to use the neural networks for multi-class classification problem, then you have to use a Relo sigmoid R10 activation functions. So how do neural network works? If we look at the graph, this is basically some layers, layers, 3 layers are there, and all the layers consist of different nodes or neurons. So this is basically the input layer, this is the hidden layers, and this is the output layers. In artificial neural networks is an interconnected group of nodes akin to the vast network of neurons in a brain. Here each circular node represents an artificial neurons. So this is an artificial neurons, this is an artificial neurons, and this is the artificial neurons. And an arrow represents a connections from the output of one neurons to the input of the other. For example, if this is an arrow, this is the output of this neuron, while this output becomes input for this neuron. Similarly, this is the output of these neurons, and this is the input for this neurons. So as we told that neural networks can be used for binary classification and multi-class classifications. So this is an example of the multi-class classifications. These are the multiple inputs forwarded to the input layers. In input layers, some weights are assigned to each inputs, and these inputs are then forwarded to the hidden layers. And then this hidden layers, inside this hidden layers, some activation functions are used, and then these activation functions decide that which input should be forwarded to the next layer, to the next output layer. So after forwarding to the next output layer, this gives us multiple outputs y1, y2, yk, and y10. For example, these are the inputs. These are the inputs for the neural networks, and these are the output of the neural networks. This example show that there are 4 outputs, means there are 4 outputs, 4 classes inside this data sets to which this example, this diagram want to classify. So input signals travels from left to right, while error signals are then travel from right to left in order to adjust the weights. How the weights will be adjusted, here a practical demonstration will be given. That's how different weights will be adjusted, how different weights will be calculated inside a particular rails, a particular node. So this is the multi-classifications, and this is the binary classifications. If you look at this, these are different inputs to this layer. And then different weights are again assigned to these inputs inside this node, and activation functions will be used which will decide to trigger the input or not, and then this is a single output. So that's why we call it a binary classification problem, because it gave me only one output. So what is the difference between multi-classification and binary classification problem? In multi-classification problem, there are more than one output, means the samples may belong to this class, or this class, or this class, while in binary classification problem, it consists of only two classes, either class 0 or class 1. Okay, in binary activation functions, the output is either a 1 or a 0. Here, to accomplish this, there is a threshold value set up. Obviously, there will be a threshold value which will decide that the incoming inputs or incoming samples belongs to which class. If the net weighted input of a neuron is more than 1, then the final output of the activation function is returned is 1, or else the output is returned is 0. As we discussed in the last lectures of the activation functions, that in activation function there is a certain threshold value for a binary classification problem. Depend upon this threshold value, the activation function decided that the incoming samples belong to any particular class. Okay, then how do neural network works? It is also called a multi-layer perceptron. Multi-layer perceptron. Why it is called multi-layer perceptron? If you look at this, there are multiple layers inside this neural networks. Layer 1, layer 2, and layer 3. So if you look at this, this is x1, x2, x3. Some inputs are coming from here. So these inputs are then augmented with the different outputs. Weight 1, weight 1, weight 2, weight 3, and weight 4, and then these are forwarded to the hidden layers. Inside the hidden layer, there is an activation functions. This is W8's importance of a point, that how much this input is important. Again, based upon some threshold value, the importance is checked here by the certain activation function. So let here we are using sigmoid activation function. So inside this hidden layer, a sigmoid functions, we are going to use a sigmoid functions. Now, what is sigmoid functions? If you remind from the previous lectures, okay, but let me show you here the sigmoid activation functions. This is the sigmoid activation function. Basically, what it did, that this function take any real value is input and output values in the range of 0 to 1. The larger the input means more positive, the closer the output value will be to 1, whereas the smaller the input, more negative, the closer the output will be to 0, is shown below. So if you look at this, if the values is more positive, look at this here, the value is more positive, which is approaching to 1, where here in this case on the x-axis the value is more negative, so that is approaching to 0. So this is the sigmoid function. This is the mathematical representation of sigmoid functions, that is 1 divided by 1 plus e minus x. What is x now? Here in this case we will practically show that how sigmoid function calculate sigmoid functions calculate the different inputs coming to the activation functions and then trigger to the next layer. So this is basically the examples. Look at this is the examples. Now, calculation for the neural networks, how activation functions calculates to be triggered or not. Okay, this is the sigmoid function used inside the hidden layer 1. So 0 1 is equal to 1 divided by 1 plus e minus f. So if you look at this, where f is equal to w1 x1. Okay, if this sigmoid function is implemented here, then this will be calculated with f1 and x1, w2, x2, w3, and x3. So this is how the activation functions will be calculated here. How the activation functions calculate different inputs combined multiplying with the weights. Similarly, another activation function will be used here, because here in output layer there are two weights or two inputs coming from the hidden layers. Now, which output will be triggered to the final output? Again, it will decide the activation functions. So here the activation functions is used will be look like that: 1 or 1 plus e minus f1. So how this f1 be calculated? If you look at this, W7 and W8. So this is W7 and W8, and then H7 H8, this is not H7 H8 but W7 H1 plus W8 or H1. Now these inputs along with their corresponding weights will be traveled to output layer, and here again this activation function will decide that which input should be triggered to the final output. The output value 03, look at this is 03. In this case, a range from 0 to 1, a value that is nearest to 1. For example, if the value is, for example, we say that this inputs give us a value of 0.75, and this will give us the value of 0.25 because the range is from 0 to 1. So in this case, if this inputs give us a value of 0.75, will return one class label representing to 1. So this is basically how activation functions calculate how it is decided that activation function will trigger the input or not based upon some threshold value. So this is the logic behind the activation functions, how activation functions calculate at a certain layers. At this layer, this activation functions will be implemented, and how this will be calculated like that, and here in this output layer, this activation function will be used. So and then this is the if we look at the, before commenting on the slides, if we look at this neural networks, this is somehow like feed forward network. Feed forward network, how it is feed forward networks? These inputs are coming from somewhere to these input layer, and this input layer send forward these inputs along with the weight to hidden layer, and then hidden layers based upon the activation function decision forwarded these inputs to the output layer. So that's why it is called feed forward network, because the inputs are flowing from one directions to other, from left to right. But in case of backpropagation work that will be discussed later on in the separate video, where if you look at this, these are the inputs, different inputs, and then these are the weights if you look at the simulation, and then net input functions, this is the net input function, here is the activation functions, and this is the output on. So every time every time the weights are adjusted, look at this, now they are forwarded even backward. So that's why it is called backpropagation networks, and the weights are readjusted every time at each iteration. In the last lectures, we have while we are covering the implementation of activation functions, there we use a term epoch. This is now one epoch. At the end of each epoch, the weights are readjusted. So this is basically backpropagations networks, neural networks, that will be discussed in a separate website. In a separate video lectures. In the next part, we will show real life examples by predicting house prices using neural networks. There we will take some features of the house, and then how these features will be propagated, forwarded to the input layers, and how input layers will forward these inputs to the hidden layers, and then how hidden layers will be forwarded these to the output layer. So wait for the next lectures. Thank you very much.